In this lesson, I will be going over graphing for ellipses as well as equations for ellipses. So to start off, let's just go over the basic definition of ellipses. And so really, again, it's a type of conic where you're really talking about it's a set of all points whose sum of distance from the foci is constant. So there's this foci, and really all the points from the foci, their distances are all equal. And so really giving just like a depiction of exactly how an ellipse looks like, I'll just draw x-axis here, y-axis here. And so looking at this, really just a sketch of an ellipse will be something like that. So more like an oval type of circleish figure. So it's more like an oval if you look at it. And so really, when we're talking in terms of terminology here, this is like the major. This is a major axis, and this one right here will be the minor axis. The minor axis. So again, the minor axis and then the major axis. Now when you're talking about ellipses, there are two different standard forms. However, I will tell you why there's no need to exactly memorize these forms, because there's a technique to really just know how to derive the equation of an ellipse. But just for the sake of it here, so for like a horizontal ellipse, right? For a horizontal ellipse, the equation is x minus h square divided by a square plus y minus k square divided by b square is equal to 1. And now when you're looking at a vertical ellipse, so for a vertical ellipse, you have x minus h square divided by b square plus y minus k square divided by a square is equal to 1. So this is what we have here. And now looking at these two different equations, we see that the values in the numerator are really the same. What's changing is the a square and the b square. If you look at the second one, clearly a square and b square switch. So here you had a square in the denominator, here you have b square in the denominator. Here you had b square in the denominator, here you have a square in the denominator. And really these variables, I guess, a and b, you should always remember that for an ellipse, a is always greater than b. And so what this means is that when we're talking about a horizontal ellipse, the easiest way for me is to really know exactly which value is a and which value is b, is to look at the x and the y. So when we know that a is greater than b, right? And the fact that a is larger than b and it's below the x indicates it's a horizontal ellipse. Here, the fact that a, being the larger value is below the y, indicates that it's a vertical ellipse. And so you can just really you can tell which type of ellipse it is. So it could be a horizontal ellipse or a vertical ellipse. The main important concept is that a will always be greater than b. So if you're given something, for instance, I don't know, if you're given, instead of a square, you may have 25 here and you may have 36 here. You should understand that when you're wherever you have the 36, right, that is symbolizing a square. Therefore, the value or the expression on top of that 36, if that has a y, then clearly it must be the vertical ellipse. If it has an x, then it must be the horizontal ellipse. So those are just the standard forms that you should know. Now, looking at just a representation here, again, this is like the major axis and the minor axis. So again, the fact that a is the larger value, we would say that this is a here, and so this value here would be b. This is a and this is b. So really, the minor axis, right? The minor axis for an ellipse is always equal to 2b. Again, b being the smaller value in comparison to a. And your major axis, that will be 2a. So you have 2a and you have 2b. And those are the lengths of your major and your minor axis as part of the ellipse. Now I'll give you an example here. So something that you may see, again, something to do with graphing and looking at the equation. So you may be given something like x minus 7 squared divided by 9 plus y minus 3 squared divided by 4 is equal to 1, right? Or something like that. And so we already know the standard forms. Now looking at this, the first thing we can say is really, we know the center of this ellipse. That's 7, 3. 7, 3 is the center for this ellipse. And looking at the, so looking at the other characteristics, before I really determine what the other characteristics are, I want to go over a specific formula. So the formula is a squared is equal to b squared plus c squared, and this is really applicable for an ellipse. Again, for a hyperbola, which I'll be going over in a different lesson, you will see that it's a squared plus b squared is equal to c squared, but you don't have to worry about that right now. So a and b, right? A and b again are the lengths of half the minor axis and half the major axis, right? As I previously showed what A and B are. And again, A is obviously the larger value, greater than B. Now exactly what is C? And to determine C, again, this is the length up to the focus point. So when I mean the focus point, right, I could draw this, but I've given this equation here, right? And so we know that this is an ellipse. Now looking at this, we can use this formula a squared is equal to b squared plus c squared. And so what this indicates is that really c squared, right, c squared is equal to the square root of 9 minus 4, because we know this is a larger value, therefore this must be the a squared. This is a smaller value, therefore this must be the b squared. And the fact that this larger value, or a squared, right, it's below the x, indicates that this has to be, right, this must be a horizontal ellipse. This is a horizontal ellipse for sure, right? And so we know that this is a horizontal ellipse, again, because we know that 9 is below the x minus 7 square. And so this is a formula, and I found c squared by doing the square root of 9 minus 4, right? Because this is a squared, we know this is b squared, and really I'm just taking that and subtracting. So I get c as being the square root of 5. And now when we draw the ellipse, right? So we have something like this. We know its center is 7, 3 here, right? Now what we're looking at, we want to find the vertices, right? But again, I wasn't really clear on what the value of c represents. So when we're talking about an ellipse, right, the focus, you have the focus, a term that you must know is the focus, right, or the foci, the plural form, and the other is the vertex. And so when you're looking at this, your vertex is going to be, so if you have, I don't know, if you have like a point here, right, this could be your point. And this is your vertex. This is your vertex, but your focus is somewhere here. We do not exactly know. And if you recall, I said the definition of ellipse is a set of all points whose sum of distance from the foci is constant. So there's a foci somewhere here and somewhere here, and we do not know exactly. The distance from the center, in this case 7, 3 is the center. The distance from the center to that to the focus point basically is equal to 7. And so really that distance to the focus point, again, this is a vertex, this could be the focus. Again, we are not sure. There's one here and one here. But when we're determining this, the distance from the center to this is equal to c, and that's what we had here. So when we're talking about the vertices, right, we're really gonna be adding. So determine the foci, right? To determine the foci, we know in this case it's 7 plus minus root 5, 3. And the reason is because we know this is a horizontal ellipse, and we know that the center, x-coordinate of the center is 7. And then we're adding plus minus root 5, right? Because again, the c is the distance to the foci, and 3, because obviously the y-coordinate doesn't change. So this is the point of the foci really. And so obviously there's one here which is represented by 7 minus root 5, comma 3. And again, so really when we're looking, we know h comma k is the center, and we're using this formula here, a squared is equal to b squared plus c squared, to determine c, which is the distance from the center to the focus point, really. And so once you know that, you really have your two main points here. So you have your 2 points here. And so really that's the basic way of sketching an ellipse. So in the later lesson I will be going more in depth more about ellipses and then also hyperbola. So thanks for watching.